If you've been following this playlist and you've been watching the past videos, we've been talking all about generics. Now, there's been a few questions about when should I really use generics? Should I really learn generics? They're all great questions. And for this reason, in this one video, we're going to be talking all about the Iterator protocol. Now, you've already seen collections, you've seen arrays, and they all implement the Iterator protocol. And so I thought this would be a great video to implement our own iterator using generics as well, so to make a custom generic iterator and to implement it, obviously. And in this we can show you really how a collection or how an array works, how a sequence works in the background just by looking at Iterator. So first of all, if you think you haven't seen this stuff already, well, you're going to be wrong here. Let's just take an array of integers, and we can say for I in items, and we can print out basically every single item here, and it will loop through, and once it's compiled you'll see 1, 2 and 3. This is perfectly fine. Now this is a collection, it's an array, right? And what we can have here from this collection is we can actually access the items iterator, and we can say items make iterator, and now we have an indexing iterator over an array of integers. So now in order to be able to loop through these here, we're going to have to use the while let I here. I'm going to say I is equal to iterator, and that's going to say next, and we're going to manually call the next function on the iterator every single time. And then we are going to print the I once again. And by no surprise, you still get 1, 2, and 3. So now what's interesting with iterators is if we do it once again, and we run it once again, you'll see we only get 1, 2, and 3 because this next function has got to the last item in the list, and it says, hey, I don't have another next here, so that's why it never goes any further. Now arrays and collections, they reset every single time for you as well, so you can call it over and over again, okay? But that's something that is embedded into the likes of collections and so on. But an iterator is not supposed to do this. Once you've called it once, it's supposed to stop, and you've got to recreate a new iterator every single time. Okay, now what's an interesting note here is that if we do it a little bit differently, and you'll start thinking, why does this happen? If we do while let I is equal to, and just come here and go directly items and make iterator, and then say next here, and you're thinking, well, I could just do this. You can see cannot use mutated member on immutable value, because when you look at this is an indexing iterator, right? And when we look at the implementation of it, it's going to be a struct, because everything in Swift is a struct already. Okay, so we need to know that it can be mutated, because it has to update its current state so it knows what the next item is. With that said, let's just jump straight in and implement this, because then you'll understand it. You'll understand it a lot better. So let's first of all say we'll say custom iterator, and this is going to be generic as well. And we're just going to say type of T. We don't care what type it is. And this is going to implement the Iterator protocol. Now the Iterator protocol, because it's generic, it's got associated type that we're going to have to fulfill first of all, and we're going to do that with a type alias, and we're just going to say element is equal to type T. Now the function that we need to implement is then the next function, and here we're going to return a optional elements, but we're going to need to mutate ourselves, so we're going to call it mutating to. So because we want to take an array, we want to take an array of items of type T. Let's just first of all say items and then element here, and we're going to have to be able to keep a reference to which item in the list we last gave for next, and when we've reached the end of it we need to return nil. So what we want to be able to do is we want to say is then the current index, it's just going to be an integer, right? And then we're going to say then the end index is then going to be an integer, and we can compare every single time whether or not we've reached the end of the array. Okay, so let's now just make an initializer, and I don't want to use the automatic one. And let's just do this. And we're going to make current, well, we're going to set self items equal to items. And now we can come and say current index is equal to items counts, and end index, oh sorry, we're going to say end index is equal to items.counts, and current index is going to be 0. So now the first thing we've got to do is we've got to check, hey, are we the first element, right? And does this items have anything in it? Well, we could start saying self.items is empty and stuff, and if it is empty, we could return nil. But we kind of have that information already, because, you know, in order for it to not be empty, current index and end index both need to not be 0. So if there is something in it, that means end index is going to be more than current index, because it's got to have something in it. It's going to be 1, 2, 3, 4, 5. So we can use a guard statement here, and this solves it a lot easier. And we can just basically say current index is less than end index, and that will tell us already whether or not we have a next element. And if we don't, then we just return nil, and that's basically finished there. So the next thing we need to do is we need to be able to extract the element out of the items using the current index, and we're going to return that. My typing's terrible today. Return that one element, but ready for the next call now. We need to increment the current. We need to increment the current index ready for the next call. And remember, the next call is going to compare this, and as long as current index is always less than end index, then we're going to be perfectly fine here. Okay. So now that we've done this, let's start using it, and we'll say custom iterator, and we'll just say 1, 2, and 3. And now when we want to use it, we can't use a for in loop, because that's needs it to be a sequence first of all, and we're not a sequence, so we have to use the while let I is equal to iterator dot next. And when we do this, you'll see once again, cannot use mutating member on immutable value iterator is a let constant. It needs to mutate itself here. So that's why we couldn't do it in the last example. We have to allow it to be mutable first of all, and then we can come to the body, and we can print it out every single time, and we get 1, 2, and 3. So let's just reuse it again, just to show you that we're still going to get 1, 2, and 3. Now, what we can do to do a little bit of debugging here is we can use then breakpoints here, and to see, okay, right now we can see current index down here is 0 and end index is 3. Okay, so we know that current index is less than 3, so we can go through to this. We've got the first element is then 1, and then we return it here, and we come to the next one. We can see current index is 1, end index is 3, and so on. We keep going through, and then we come here, we say current index is 2, and we have the element is then 3, and we then return this, and now we're into the next loop. All right, so we see we go out to nil there, and we come in again, and we go out to nil there, and so on. So you can see that it came through, and it never had a chance to get down here, because the current index was always more. So let's just come to here again, and let's move our breakpoint to there instead, and look when it hits the return nil instead. So now we see current index is 3 and ending index is 3 as well. So we never fulfill this, even though we know where we know that we're in a second loop. So in order for us to be able to solve this, we've got to have like a reset function on here. And we can do that just by saying function reset. Now, in order to be able to reset it, we're just going to set this current index to 0. That's it. So rather than saying, rather than coming straight to this, we need to say iterator and then reset. And when we run this once again, you'll see here we get 1, 2, 3, 1, 2, 3. So this is something that you've got to think about when creating custom iterators, that they once they've got to the end, that's it, they're done. They don't go any further, and they're not supposed to go any further. They're supposed to stop, and there's not supposed to be there's no ruling that which element it has to give. All right, so you can't be certain that if you call it twice that you're going to get the same order. There's nothing to say that it has to be in the same order. All right, that's where the likes of collections and or arrays and so on come into it, that they are ordered lists. Okay, that you always get the same order, but an iterator doesn't make that promise. So you could get, if you wanted to compare the results when you call it twice, then they might be in a different order all the time. So that's all the iterator protocol cares about. And I would suggest looking at the documentation to see all about this and how they work. With that said, I hope that this video has introduced you a little bit more to why it's really important to understand, first of all, how an iterator works, to understand what associated types are, and also because at one point you're going to need to learn how to use the constraints, which we talked about in previous videos, is how to compare associated types with other associated types using constraints, using the where. And this is a good thing, because if you want to compare or take two custom iterators as parameters for another struct or something, but you want to make sure that their T element is the same, or they're both equatable, or they're both comparable, and so on. So this is, it's important to understand. It's important to understand generics, and it's also important to understand what an iterator is. And when we say let's iterate over these items, this is exactly what we're talking about. All right. With that said, I hope that you've got something out of this one video. I hope that you learned something from it as well. And I hope this clarifies why you should use generics and why generics are so powerful as well. With that said, don't forget to like, subscribe, share, and do all of the other social media things that you can do out there. If you do have any questions, feedback, or concerns, then let's start a conversation in the comments section down below. With that said, thank you very much. My name's David Thorne, and I'll see you in the next video. Ciao, ciao, and goodbye.